Hello again, everybody, and welcome to the next session of the 2024 Robotics Application Conference presented by Corber. I'm again Tim Culverhouse, the Editorial Director of Robotics 24/7, serving as the moderator for this and all the sessions of RAC 2024. And right now we are in our cobots session. Now, the title of today's presentation is Hybrid Autonomy Through the Sense of Touch, How Haptic Feedback and AI Shape the Human-Cobot Relationship. Now, before we begin this presentation, I'd also like to thank our sponsors for the cobot track, and that's Universal Robots and Invista. Now, further along for our audience today, before we start the presentation and discussion, let's go over some housekeeping as part of your viewing experience today. If the slides accompanying today's discussion aren't advancing, please hit the F5 key to refresh your browser window. Viewers who'd also like to download a PDF of today's slides and other supporting documents from our sponsors, Universal Robots and Invista, can do so by clicking on the blue paperclip resources box at the bottom of your browser window. You can also access these resources on the Cobot session page of RAC 2024. Now, if you're still experiencing any other technical difficulties with today's program, please click the orange question mark box at the bottom of your console for further help and instructions. Haptic feedback provides real-time information about forces and interactions between the robot and its environment. The relationship between humans and cobots requires specific sensors, forces, and data to generate the precise movements required for applications and for operator safety. Innovations in force torque sensors provide the haptic feedback required to safely operate cobots in various industrial environments. And further development of artificial intelligence will expedite the collaborative element of these machines and their human counterparts. Now, this session will examine the hardware and software components associated with cobots and how technological advancements will further define collaborative robots and their role in the relationship with humans. And I'll speak about this topic and highlight its importance in collaborative robotics. I'd like to introduce our guest for today's program. Clyde Lika is the co-founder and CEO of Boda Systems. And Clyde, thank you so much for joining me today as part of RAC 2024 and discussing these issues and features of sensors on cobots. Clyde, over to you.
Thank you very much, Tim, for having me. A pleasure to be here, of course. Boda Systems' mission is to give machines the sense of touch. Our company develops a robotics sensing platform that gives robot the ability for safe and productive human-robot interaction. We're located in Switzerland, and our team is mainly engineers with robotics background. We have customers all around the world, including some of the big tech giants. So, I'll be talking to you today about challenges in industrial robotics and what's done nowadays to address them. And what can be done in the near future in order to increase adoption across industries. What technologies are there today that they haven't been adopted yet? We believe that the concept of human-robot or cobot collaboration is great and has many benefits. We mainly think that robots should be completely autonomous, and sometimes I'm wondering why. I don't know why we think that they should be completely autonomous. There is absolutely no reason, since the concept of collaborative robots is exactly that. The cobots should be assistants of technicians, of workers in industrial environments. When a robot does not perform correctly what the worker does not perform correctly what needs to be done, then the worker can intervene and help it accomplish the task. Haptic feedback, coupled with the new advancement in AI, boosts exponentially this idea of robots learning by humans by demonstration. Like a senior technician, for example, would teach to a young apprentice. In the video, in this video here, you can see how a human is teaching a robot to clean a surface by using the haptic feedback. I'll let you see the video to see how reactive and how easy it is to program the robot just by demonstrating the forces and the position it needs. Slowly, after a while, the robot teaches itself on an AI. This is one of our customers that have been using a robot with Universal Robot. So, force sensors or tactile sensors or torque sensors are key components for all technological trends in robotics. For AI and machine learning, for collaborative robots in new applications such as welding, polishing or sanding, mobile manipulators in automotive, logistics, and aerospace. Digital twins to save space and time, either online or offline. And last but not least, humanoids. Humanoids. This is a very popular topic nowadays, but we cannot see deployments yet out there. And we can also talk about it another day. Coming back now to industrial applications, we see that some of them that require the sense of touch are developed already, and they exist. We, internally at Boda Systems, we have developed quite a few of those, and our customers too. Although the adoption suffers is quite low, I would say. The adoption of robots across multiple industries can happen once the total cost of ownership drops to a level where even small and medium enterprise can afford. This is the only way where humans can work with robots in a variety of applications and gather diverse data for AI modeling. In order for this to happen, they need to have increased dexterity from what they have today. They need to be easier to use and have low upfront investment such that the risk for a business owner drops. Robots with the sense of touch are easier to use and easier to program. You can see to the left side of this slide an industrial robot that is performing handling, polishing, grinding, and assembling, and it's easy to use. On the right side, you can see some robots for services. This is a video that we're going to play. Early research on AI for robots has shown that learning by demonstrating the applied forces and touch is the key to unlock the adoption of robots across multiple industries, and it's probably a dominant modality in AI for very efficient learning. Our sensors, our sensing platform, let's say, are extremely compact, they are lightweight, they are fully integrated with electronics, and they are very easy to use. And we provide, for these reasons that I explained to you before, open source software to be used by all the ecosystem in collaborative robots and other type of robotics. And that's exactly what people need to see nowadays. So talking about is the use, practically speaking, that would mean that the human physical skills need to be transferred from a skilled technician in production to a robotic system without the need to code, without complicated instructions, and no complicated bulky hardware to handle. This is exactly why we see these trends in robotics nowadays of more mobile robots, more robots that are able to collaborate. I would like to conclude. Thank you very much, Tim, for having me here today. If you would like to connect with us, please feel free to scan this QR code or visit our website.
Clyde, thank you so much for walking through some of the sensor elements that are associated with collaborative robotics and what Boda Systems is doing in conjunction with Universal and then Invista as well, and the other elements of collaborative robotics across the industry. Wanted to ask you a couple of questions here about cobots and the relationship between humans and robots. And I guess the first one that I had for you, Clyde, and in talking with people across different industries at different trade shows, the term cobot, collaborative robot, isn't really defined. There isn't a widely accepted definition throughout the industry. So I'm just curious if you could elaborate on what the term cobot means to you and what you guys are doing with your sensors.
So the term cobot for us means that the robot is collaborative is mainly defined by a couple of standards at the moment. It cannot be subjective. So once we agree all together that this is the industry, this is the robot, this is a cobot, the collaborative robot, then I mean like this is exactly what a cobot is. It's a robot that is easy to work with at the same environment, let's say.
How important does safety play in that in terms of working with people in a space, confinements with humans and robots? And then the follow up to the collaborative element with that is the sensors and the feedback. How are you guys developing your sensors with safety in mind in that sort of feedback that allows the human to interact safely with it, but then also the robot to understand what it needs to do, some of the industrial applications?
So that's a very good question. In terms of design, we design and develop our sensors with all the safety in mind. I mean, like we have multiple algorithms that they enhance the redundancy and the safety there internally, but also thinking as a holistic approach, the whole application, because the solutions that we provide out there, they are made not to do that, not to be able to harm someone. So there are multiple ways to see that. Yeah.
And in that safety element, there are, as you mentioned before, some robots have the gates and fences around them for them. As technological advances come in the next handful of years, and we're starting to see it already with artificial intelligence and machine learning, I'm curious if you could, maybe put your predictive hat on to look down the road. What sort of technology and either hardware or software components will allow humans to work more closely with these cobots and, by definition, make cobots more collaborative with those around them in their environments?
That's a good question. Is it possible to repeat it again, please? Because I lost you a little bit.
Of course. Yeah. So I guess the main element here in the collaborative side of things with these machines is that as technological advancements continue developing across industries, what do you predict either from the hardware or the software or the data collection, the feedback with the sensors? What sorts of things in the next handful of years will continue evolving the term collaborative and cobots and allowing them to be used either more efficiently or more safely across different industries?
So in general, data collection and analysis and all these things are becoming now increasingly integral to the operation and improvement of collaboration of collaborative robots. So by continuously, let's say, gathering data on how robots interact with their environment and human coworkers, we can see a couple of patterns, predict some potential issues that may happen, and make adjustments to improve safety and efficiency. This data can help refine the algorithms that control the cobots and making them smarter and more reliable over time and even more productive. For example, if data analysis from the data that we have shows the cobot consistently struggles with a particular task or environment, then we can make some adjustments to the robot's programming so the motors are not heated and it's not for the task itself to mitigate these issues. Moreover, the data collection allows for real-time monitoring of cobot performance, which can be critical in preventing accidents and equipment failures. As we move forward, I expect that the role of data will only grow, and therefore we're going to be leading towards cobots that are not just reactive, but proactive to ensure safety and enhance collaboration with the humans.
I was going to ask as a follow-up to that, do you think we'll need advancements in artificial intelligence to turn that ability to move and manipulate and interpret this data will help go from a reactive motion to, like you just described, that proactive motion? Is AI really the key to unlocking that?
Yes, for sure. AI is one of the biggest, let's say, have shown great advancement nowadays because you can see out there, I mean, like that there, if you gather data and you see what's going on with, for example, in maintenance, you have this predictive maintenance. And although we had so far many ways to predict, we were always very bad at predicting if when a component is going to fail. Besides having empirical data with AI, it's much faster and much easier to do in that industry. The same is going to happen with robotics. We're going to see if, let's say, for example, while gathering data from something that has happened in a specific environment with a couple of equipment around that may be harmful and may lead to a harmful situation where someone was injured. I think we could also predict something like that. But aside that, I mean, like by having also all the necessary sensors like LiDARs or cameras and force sensors, we will always be able to mitigate and have double or triple layers of safety. That the robot would be able to restrict the forces that are applied and we don't proxy into any danger.
You titled this presentation around the term shared autonomy. And as you were going through describing the feedback elements and again, that human and cobot relationship, I'm wondering if you can elaborate a little bit more on why shared autonomy is how you described this relationship and what that entails between the human that is working and manipulating and understanding everything that is going on with the cobot in an industrial sense, and how shared autonomy will also continue to evolve as technology does.
Yeah, I talked before about the hybrid autonomy. Shared autonomy is a term that I recently saw from, and it's a very nice term to be used because it's actually collaborative robots. I took it from Bernd, the founder and CEO of 1X, the humanoid, that he was talking about that robots should be around people, so they learn from them as well. If a robot does something bad, I mean, like then the human can intervene and help it. So it's a fascinating concept and a critical component of how collaborative robots are integrated, cobots, let's say, are integrated in human workspaces. Essentially, what does that mean? I mean, refers to a dynamic partnership between a human and a robot, where we see the control is transferred fluidly between the two depending on the task at hand. So, for example, a cobot might handle the bulk of a task, like lifting and positioning a heavy object, while a human fine-tunes the final placement. So you put a robot to lift up a big box and the human to help it finalize where it should be putting the box. This relationship now is evolving rapidly, and as both cobots and humans adapt to working together. while humans are learning how to work with robots, the same way happens the other way around with artificial intelligence. It's a vice versa thing. However, there is, let's say, a lingering perception among the general public that robots are taking away jobs. That's not an issue, to be honest. In reality, cobots are often deployed in roles that are either dangerous, monotonous, or where there simply aren't enough human workers available. By taking over these roles, the collaborative robots free up humans and workers and make them focus on tasks that require creativity, problem solving, and interpersonal skills. Areas where humans excel and robots currently cannot match. Changing this perception requires education, demonstration, and time. People need to see these collaborative robots in action, not just as job takers, but as enablers that allow them to perform higher value work.
Part of that, and I think this will be the last question that I have to ask you, Clyde, is teaching the robot. And in terms of even going back to that video you showed in the polishing and finishing segment, what is the learning curve for the people working alongside the robots to teach them and move that and manipulate that robot to do this operation? How quickly do you think we can have people working alongside robots and learning this training and teaching the cobot what it needs to do before it's able to do it on its own? And as you just described, let humans do the interpersonal sort of stuff and what robots aren't good at.
So the learning curve, this is highly dependent on how much resources, let's say, society has, and how open people are to that. To be learning is like the same thing happens with our smartphones. A couple of years ago, we had smartphones, and many people wanted to just keep, the old technology, work with that. They were very hesitant because they didn't want to learn new tools. I believe it's the same. It's going to be, let's say, they don't have the same time. It's going to take the same time because while we're working in the whole, robotics community on making robots easier to use, these things are going to happen, and the robots are going to really be easy to use, up to a point that it's going to be as easy as it took us to learn a smartphone. And if that happens, we're going to have tools that are not only static anymore. Smart tools like smartphones are going to be tools that they're dynamic, that they move around, and they can support us with all the physical activities. And this is the role of collaborative robots. This is the role of all modern robotics.
Well, I'd like to say thank you for the questions, the answers, and the presentation. It's all very helpful as we continue defining the term collaborative robotics and cobots, and then the role of these sensors and feedback with humans working alongside these machines. It's very insightful and very helpful. And I'm going to sign off here in a moment, but I want to say thank you again for joining us, Clyde. I greatly appreciate your time.
Thank you very much.
And for those that are watching, just a couple of reminders before we sign off here and move on to our next session that once again, a PDF copy of today's presentation along with other related content from our sponsors, Universal Robots and Invista, can be found in the resources box on your console along with the RAC session pages. Before you sign off at this time for our viewers, can you please fill out the feedback survey that's also open on your console? Thank you in advance for doing it. It helps us develop better webinars in the future and also RAC events moving forward. And thank you once again for attending this cobot session in our Robotics Application Conference 2024, once again titled Hybrid Autonomy Through the Sense of Touch, How Haptic Feedback and AI Share the Human-Cobot Relationship. And a special thanks once again to our session sponsors, Universal Robots and Invista, and our presiding sponsor of RAC 2024, Corber. Now, the other sessions of RAC will be released throughout the day. Some have already been released, and you'll receive everything in an email so you can view everything on demand throughout the day and for whenever you have the viewing pleasure. And you'll get more information with everything later on throughout today, and we appreciate it. So on behalf of our guest, Clyde Lika from Boda Systems, I'm Tim Culverhouse, Editorial Director of Robotics 24/7. Thank you again for joining us in our Cobot session, sponsored by Universal Robots and Invista, and for our 2024 Robotics Application Conference, sponsored by Corber. Enjoy the next sessions, enjoy the ones that you've already taken care of, and we look forward to following along with you and the rest of today. Thank you so much. Bye-bye.